If you think back to when we did linear equations, you might remember that linear equations can have one solution, no solution, or infinite solutions. The same is true for systems. Now, so far, the ones that we've done have all had one solution. But what does it look like if it has no solution or infinite solutions? So we're going to be able to identify linear systems in one of those three ways: one solution, no solution, or infinitely many solutions. And then we're going to model real life problems using a system of linear equations. I'm going to show you two ways to just be able to tell whether a system has one, none, or infinite solutions. One way you can do this is put these in your graphing calculator. Now, if you don't have your own graphing calculator, you can use Desmos online or get the Desmos app for your device. But I can also show you what these look like algebraically to be able to look at it and just tell whether they're going to have one, none, or infinite solutions. So let me zoom in here on number 1. And again, you can plug this into Desmos so you can see what it looks like if you don't have your own graphing calculator. What I'm going to do is I'm going to write these equations both in slope-intercept form. So y equals negative x plus 3. Y equals negative 2x plus 2. So to tell what kind of system we have here, you need to look at two things. You're going to look at their slopes and their intercepts. So this is an example of a problem that we've been doing. They do not have the same slope. They do not have the same y-intercept. So they're going to intersect at one point. So if you're looking at it on your calculator or if you just solve it, you can find that it has one solution at negative 1, 4. All right, number 2, I'm going to write these in slope-intercept form. This is going to take a little bit more work, just showing my steps. So I've got negative 2y equals negative x minus 6 divided by negative 2. So y equals 1/2 x plus 3. And then this one, add 2x to both sides. 4y equals 2x plus 12. Divide by 4. Y equals 1/2 x plus 3. So they looked like they were different lines when they were in this form, but when we wrote them both in slope-intercept form, let me put a box around that, we can see that they are the same line. So if I were just to do, let me do a quick little sketch over here. I'm at positive 3 and my slope is 1/2. Those are the same line. Remember, a solution to a system is where the lines intersect. Well, where do these two lines intersect? On top of each other. So if it's the same, these are the same line. So that's going to be a special type of system. You might be thinking about what the answer to that is. Is it one solution, no solution, or infinite solutions? All right, number 3. Again, I'm going to write both of these in slope-intercept form. So I've got y equals negative 3x plus 1 and y equals negative 3x minus 2. Again, I'm going to do a quick little sketch here. I'm going to do this one in red and this one in blue. So my intercept in red is at positive 1, and I'm going to go up 3 over 1. I'm just trying to give you kind of a basic idea, that was not a very straight line, of what this looks like. And then at negative 2, up 3 over 1. So hopefully you can see what I'm getting at here. These two lines have the same slope or the same rate of change, but they have different intercepts. So they are parallel lines. So you might think about, is that going to be one solution, no solution, or infinite solutions? All right, number 4. Let me scroll over here. Okay, I can already kind of tell where this is going. I hope you can too, but I'm still going to write it in slope-intercept form. So I'll show the middle step here. Negative y equals negative x minus 2 divide everything by -1. Y equals 1x, or just x, plus 2. And this one, subtract x from both sides, so -y equals -x plus 3. Divide by -1. So y equals 1x minus 3. So same as last time. I've got the same slope, which is 1. We just didn't write it there, but different intercepts. So these are parallel lines. All right, number 5. I'm going to write both of these in slope-intercept form. So I've got -y equals -2x plus 3. Divide by -1. Y equals 2x minus 3. And this one, second one, y equals -3x plus 1. So I've got different slopes and different intercepts, so I'm going to have an intersection or one point. And if you do it on your graphing calculator, you might see they intersect at 0.8 and -1.4. All right, number 6. Let's see, I'm going to have -3y equals -x plus 2. Divide by -3. So y equals 1/3 x minus 2/3. And on this one, I'm going to have 3y equals x minus 2. Divide by 3. So that becomes y equals 1/3 x minus 2/3. So these are the same line. All right, next example. Number 7. I'm going to write them both in slope-intercept form. So -4y equals -2x plus 6. Divide by -4. So y equals 1/2 x plus 3/2. Oh, minus 3/2. Oh, I almost missed that sign there. And on this one, -2y equals -x plus 3. Divide by -2, which is y equals 1/2 x minus 3/2. So they are the same line. All right, number 8. -y equals -2x plus 3. Divide by -1. Y equals 2x minus 3. And this one is y equals -4x plus 2. So I have different slopes and different intercepts, so they're going to intersect. If you do this on your graphing calculator, they intersect at about 0.83 repeating, -1.3 repeating. All right, so what does this mean? Let me zoom out here. Which systems have one solution? Okay, well, what is true of a system with one solution? It's going to intersect. So something that intersects has one solution. So that's going to be numbers 1, 5, and 8. All intersect at one point. Lines that do not have the same slope are not parallel. They're going to intersect at one point. Which systems have no solutions? What is true about those? Well, if we're looking for an intersection, then if they don't intersect by definition, that means parallel lines will never intersect. Therefore, they have no solution. So that was 3 and 4, right? And then which systems have infinitely many solutions? What is true about those? Infinitely many solutions means the lines are on top of each other. They share a line, so all points on the line are solutions. So same line or identical lines are going to be infinite many solutions. So that's 2 and 6 and 7. All right, moving on to the next page. So to summarize what we just said, everything up to this point has had one solution, but now we are looking, this is the one solution example, but now we're looking at parallel lines that have no solution because they never intersect, and infinite solution, which is the same line, the lines are on top of each other. So how can we identify those? You can graph them, of course, and see what the graphs look like, or you can use the other strategy of looking for same slope and what is the y-intercept. So in these, I'm going to write both of these in slope-intercept form like I did last time. So this in slope-intercept form is y equals negative 2x plus 5. And this one is y equals negative 2x plus 1. Okay, so I have the same slope, but different intercepts. So that means that these lines are parallel. How do we know they're parallel? Because they have the same slope, but different intercepts. All right, example number 2. All right, it says this system has infinitely many solutions. How can we tell? Again, let's write this in slope-intercept form so we can see y equals 2x plus 3. And this one I'm going to have 2y equals 4x plus 6, divide by 2. And lo and behold, when you simplify it, it's y equals 2x plus 3. So why does this have infinitely many solutions? In slope-intercept form, they're identical. Y equals 2x plus 3. Okay, so they are the same line. And we know they're the same line because in slope-intercept form, they have the same slope and the same intercepts. All right. Solve each system and interpret the results. So here's a good time for you to pause, either graph these on your graphing calculator or Desmos, or write them both in slope-intercept form and decide, is it one solution, no solution, or infinite solution? So pause and try number 1. Okay, for this first practice problem, when I wrote both of them in slope-intercept form, they were both y equals negative 3x minus 1. So we know this is infinite solutions because they have the same slope and the same intercept. All right, try number 2 on your own. So pause and try it on your own. All right, for number 2, the first equation in slope-intercept form is y equals 1/2 x minus 5 halves. The second one is y equals 1/2 x plus 1/2. So what I noticed is they have the same slope, which is 1/2, but different intercepts. So I know something with the same slope and different intercepts are parallel lines, so they have no solution. Let's move to the next page. In these problems, we're asked to solve each system and then interpret the results. So we're going to look and see algebraically, what would this look like if we solved it? So for number 1, we can solve using any method that we choose. Since neither one is set up as in slope-intercept form, neither graphing nor substitution is going to be very favorable here. So I'm going to use elimination and multiply the first equation by 2. So that'll give me 4x plus 2y equals 8. So this way, my negative 2y and my positive 2y will eliminate. So I'm left with ax equals 8. Divide by 8, so x equals 1. Okay, now I can plug that into either equation. I'm going to choose the first one. So 2 times 1 plus y equals 4. So 2 plus y equals 4. So y equals 2. So I have a solution, which is 1, 2. So my interpretation of this is there is one solution. We know that because it works out for one value of x and y. All right, next problem. I'm going to solve this one by elimination again because I can multiply the second equation by a positive 2. So when I do that, I get negative 6x plus 2y equals 24. And I'm going to write the first equation underneath it just so we can kind of see what we're looking at. Okay, so what I see here is I have negative 6x and positive 6x. Those eliminate. Positive 2y and negative 2y, those eliminate. So I get 0 equals 34. Is that a true or a false statement? That's a false statement. Therefore, there is no solution because 0 does not equal 34. If it's no solution, then we can say that we know if we graphed it, they would be parallel lines. And you could confirm that too by writing them in slope-intercept form and just seeing if they have the same slope and different intercepts. So you can always check your work. All right, number 5. I'm going to multiply the first equation by 2. And so I get 6x plus 2y equals 8. So what I notice here is my negative 6x and my positive 6x eliminate. And my negative 2y and my positive 2y eliminate. So I get 0 equals negative 8 plus 8. That's 0. That's a true statement. So therefore, it's going to be infinite solutions. And I could double check myself to make sure it's the same line by writing both in slope-intercept form and seeing if they are in fact the exact same line. So, closure. How do the number of solutions of a linear system relate to the graph of the system? Okay, so I want you to think about what does one solution look like? What does no solution look like? And what does infinite solution look like? So pause and fill those out and then check your answer. Okay, so one solution, this is probably the most common one point of intersection, and that's what we've been doing on all the previous lessons. No solutions, 0 points of intersection. So those lines will be parallel if you graph them. If you're doing it algebraically, they will have the same slope but different y-intercepts. Infinite solution, infinite points of intersection because they are the same line. If you're doing it algebraically, they will have the same slope and same y-intercept.